In this video, we're going to look at some miscellaneous overflow vulnerabilities in Windows, in particular, section overflows and how those occur. So here I have a very simple program. I'm declaring a few variables that are global in scope, available to all of the functions in my little C program here. I've set up a buffer of 16 bytes and two function pointers. I've initialized all these variables because global variables that have been initialized are stored in a different section. In my main program, I create a handle to a module, and I use the Windows load library function to load the MSVCRT DLL, and then within that DLL to find a couple of standard functions such as strcpy and printf, which we've talked about previously. I then use the function pointer for strcpy to copy a command line argument into global buff. There's a possibility that this is going to be overflowed if the user inputs more than 15 characters on the command line. After that has been done, I use the second function pointer to call printf. Now, this could fail if I've overrun that buffer, global buff, so that I've also overwritten my function pointer that is supposed to go to printf. So that's the simple program that we are going to exploit here. If I pop over to Unity, I already have the program loaded, and we can go ahead and run it. So here's my disassembly window. Here is my main method. You can see calls to load library, get proc address, etc. So set a breakpoint right here by hitting F2, and I'll go ahead and run this program. So here I am at my first breakpoint. I'm going to load the library, the Microsoft C runtime library. I can see here that my return value is stored in EAX. And if I look over here in my registers, I can see that it's been stored successfully in EAX. All right, so as we go through here, notice what's going to happen. I have that return value. I'm going to store it. I'm getting the address of strcpy and storing that in my second function pointer. And here, notice immunity has determined that EAX contains the address for strcpy, and it is going to call that function. So here we go, stepping through. And now we're going to make a call to strcpy. We can see the string that's been copied. I just have a series of A's, B's, etc. And I can use this to determine how far I need to overflow my buffer in order to make this work the way that I want it to. So if I step through here, here's my printf call, or what it is supposed to be a printf call. So now I'm going to make my printf call. And sure enough, I have an access violation on 6D, 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 6C. So once again, if I look over here at EAX, I can see those values. Here, 6D is the ASCII code for the letter M. It also looks like I made a slight mistake and put one too many L's in here. My suspicion is that we are looking at 402030. So this is just how far I have to go. So starting here, invite hex 30, which corresponds to the 48th byte, I'm going to overrun that function pointer by overflowing my buffer. In immunity, you can go to view and you can view the memory. And when you do this, you will see a memory map. And notice there are a bunch of sections that are displayed here. The text section is used for source code. So this is the source code from your program. It's shown here in assembly, but this is pretty much where your code is stored. And then we have these other sections such as data, R data, BSS, I data, and for the dynamic link libraries that are being loaded as well. So here we have our DLL, our standard one. We also have kernel 32 that gets loaded and NTDLL that gets loaded. and they each have their own sections. So in this example, we overran the data section, but that's not the only section that could be overrun. So here you can see our buffer, which starts and ends on this first line, and we overran it. And it wasn't until we got down here at the 48th byte to where we were hitting our other values. Often there's alignment issues whenever you're dealing with this kind of code that's been compiled. Obviously, you could use other sections, including data sections and other libraries that are loaded, and you could overrun those as well. One other tool that you could use is a PE Explorer. The PE Explorer allows you to look at a file and look at the different sections in the file. So for example, here's my data section. It's a lot more interesting to look at them with immunity. And of course, if I look at my data section, I will get my code. And once again, this tool does not provide me with a nice disassembly of that code. And that's better done with immunity. There's also a process executable block, which is something that's created for every process, can be overrun. There's also something related called a TEB, a thread execution block, that can be overrun as well. So generally speaking, if you have something in some sort of section or division, there's probably a way to overrun something in that section and overwrite something else.